Okay, your title for your last set of notes ever in your life, in Algebra 2 at least, is 10.2. We are verifying trig identity, so we're still taking what we just did in 10.1, and we are just mixing them together. So you still need that chart. So I would have that chart handy at some point or in some way, in some form or another. Whether it's your book. Yes. It's because I wrote it on a board. Or page 655 in your book. It is in chart form. Just putting it out there. Whichever one you feel the need to do. Okay, so it does give you a little hint of how to do this. It gives you little steps if you'd like. I don't think it'll help, but I'll read them to you and you tell me if you like them. Okay, it says, step 1, to simplify one side of the equation until each of the two sides are the same. It is often easier to work with a more complicated side. Step 2, transform the expression into the form of the simpler side. They mean the same thing. AKA, the hint is, if you have two sides of the equation, usually simplify the more complicated side. Okay, that's the big hint for this. So here is an example. There's not a lot of notes, it's just examples. So the left side has the fraction. It says sine squared of theta on top, all over 1 minus cosine of theta. Had to make sure I was right before I wrote it. All equals, man, I have this itch in my throat, 1 plus cosine of theta. So you always pick the side that's more complicated because this over here, this right side, you can't do anything with this. The number 1, you can't really do anything with it. And this cosine is not squared, is it? So it's not an identity. So you literally cannot do anything with that. So that's why you always pick the most complicated side. So just kind of ignore the right side for now and go, okay, I want to simplify this. Anytime you have a fraction, you want to not have a fraction. So you want to make it so it's not that way. Now, 1 minus cosine. Because that cosine's not squared, can we replace that with anything? No, because the cosine is not squared. If it was squared, sure. Because then it would be that Pythagorean identity. But since it's not squared, there's nothing you can replace that with. Since there's nothing you can replace that with, you go, how do I get rid of a denominator? Yes, multiplication. How do you get rid, oh boy. Okay, so Isaac was right. We're going to multiply the top and bottom by, not by this, but by its inverse. So by its conjugate. Do you remember what the opposite of 1 minus cosine theta is? I just almost said it. Yes. You're going to multiply the top and the bottom by 1 plus cosine of theta. I didn't have enough room. So when you have a binomial in the bottom, you multiply by its conjugate, which is the same thing, but whatever the sign is, make it its opposite. So you're going to multiply the top and the bottom by 1 plus cosine of theta. So in the top, you distribute. So sine squared times 1, I know it's hard to see, is sine squared of theta. Actually, I would just leave it alone for now. Just leave the top, do not multiply it. Because you always want to see if you can cancel it out. So just rewrite it. Because you want to see if you get rid of the denominator. Leave the top alone until you can see if you get rid of the denominator. What happens? So I'm just going to rewrite this so you can see it. 1 plus, this is going to go good. Cosine of theta, 1 minus cosine of theta. Okay, so that's what it was. You just couldn't see it, so I rewrote it for you. So this denominator, we want to simplify this. How do we multiply these two things? FOIL. When you FOIL these, when these things are exactly the same, but the signs are different, what happens? Does anyone know? To skip the steps? Huh? There's no middle terms. When you FOIL, you're only actually have to do F and L because the O's and I's cancel out. If you don't believe me, you can do the whole FOIL and O and I will cancel out. Oh yeah, sorry. My bad. I couldn't read it up there. That's why I rewrote it. Couldn't read my own handwriting because it was too smushed. So we're going to FOIL this, but the O and the I are going to cancel out. So you just do first and last. So 1 times 1 is 1. I'm just going to rewrite the bottom. Rewrite the top. So 1 times 1 is 1. Positive times negative is a negative. Cosine times cosine is cosine squared of theta. Okay. Now, Brad, 1 minus cosine squared. Is that a trig identity? What can this all be replaced with? Just this guy. This can all be replaced with sine squared. So we have the top. Ladies and gents, what do you see about the fraction? Same thing on the top and the bottom. How do you know you can actually cancel those out? What? Because it's a fraction, and also because this guy right here, this is multiplication. If this would have been addition, you can't cancel them out. But since this is multiplying by all of that, you can cancel them out because you could separate them into two fractions. So since this and this are the same, they can cancel out. So you're literally left with 1 plus cosine of theta. And then we have to think, oh, that's simplified. Well, what was the right side of that equation again? 1 plus cosine of theta. Are those exactly the same? Yes, I can. That's why I didn't erase it. No. Pythagorean identity. I like the way you said that. Oh. Okay. Can I erase this? Okay. Okay. It would help if my markers were like smaller and writing. A little pointier. Hey, Lincoln, is there any little markers up in that bin up there? Like the silver bin? Or just bring the bin to me? Let's see if any of them work. These ones write too fat. Okay, let's see if this one works. Okay, let's try this one. 1, ooh, look how small that is. Okay, 1 minus cosine of theta all over 1 plus cosine of theta. That rate's so much better. And it's legible. All equals. Oh, that's just wrong. Oh, that's just wrong. I apologize in advance. Cosecant of theta, this is in parentheses, minus cotangent of theta, close your parentheses, squared. Technically, look at it for a second. Which side looks more complicated?
Yeah, but
so the right technically is more complicated, and yes, Isaac is correct. It's because of their trig functions. Because the left side is just cosine and they're ones, but the right side, yes, it has foiling, and you're like, that's easy, but think about what those trig functions are and think about what happens when you foil them. How much work that's going to turn into. And I'm looking at it and it's not going to be pretty. So this guy right here, so we're going to ignore him, which is good because I'm going to need this space. So we're going to just deal with the right side. This turns into what? How can I rewrite this? Cosecant minus cotangent. Yeah, we're going to multiply them times themselves, yes. I'm definitely going to need 2 boards for this one. And since I'm just rewriting it, remember the sign, the subtraction just stayed the same. And then again, what operation or what method are we going to be using? Foil. So actually foil it, it is going to get a little insane. It's okay. So F, you're going to get, yep, cosecant squared of theta. O, F times O. You just put negative. Oh, it doesn't matter. I would just put, it really doesn't matter. You can do alphabetically if you'd like. So cotangent technically comes before cosecant. It doesn't matter. Oop, I spelled it wrong. So cotangent times cosecant. And then cotangent minus times cosecant. Here we need another line. What can you do with the middle two? So it'd be cosecant squared of theta minus, I have 2 of the middle ones. So 2 cotangent theta cosecant thetas. And then plus cotangent squared. You never know. Alrighty, I hope not too, because this is ugly. Yes, what versions of them would we like? They're, because cotangent has many forms, doesn't it, technically? You can put it in its tangent form, you can put it in its sine and cosine form. Again, think back to the original problem. What are all your answers in? Okay, so you would want all your answers in sine and cosine form, so no tangents. So this one turns into cosine squared of theta over sine squared of theta, right? Doesn't it? No. I was looking at cotangent. I'm sorry, hold on. Yes, hello. Yes. No, I already told her I gave her all she had for the rest of the year. Bye. Okay, cosecant, what's its sine or cosine form? 1 over sine. Yes, since cosine is squared, sine has to be squared. 1 squared is just 1, so it doesn't matter. Then we put the minus sign, right? 2, you could just leave it as 2. If you want, you can really put a 2 over 1. Put everything in fraction form if it makes you feel good. Cotangent, how do we write it as a fraction? This is not pretty, by the way. I apologize. Cosecant again. 1 over. Same thing without the squared. Oh, geez Louise. And then cotangent squared. Cosine squared over sine squared. Looks like a lot of crap, doesn't it? But look at this denominator in the middle. This is all one term, yes? If I made this one fraction, because it really is all together, what's its denominator? 1 times anything is 1, so ignore the 1. It's sine squared, yes? What do you notice about every single one of these? If they're all have the same denominator, what can we do with them? Turn them into one big ugly fraction. Because this, our original problem, our final answer on the left is one ugly fraction. So you want it to be all over sine squared because it's just going to be one sine squared, right? Because they all have sine squared on the bottom. So sine squared of theta is on the bottom. And on the top, what are you going to write? 2.
Minus cosine cubed. No, wait. No, but there's 1. Hold on.
1 minus 2 cosine of theta times 1 doesn't mean anything, plus cosine squared. You literally just bring it together. I'm going to need another board. I'm going to rewrite this up here because I just... Okay. All I did was transfer that to the other board so I didn't have to try to write while that was jabbing me in the stomach. Okay, now we technically need to simplify the top and the bottom separately from each other. Now the top, do you notice how they both have the same trig function? This has a number, that has a number. If I'm just going to show you something. See how this is square, this is not squared. I can reorganize this if I wanted to. I'm just going to flip it around so it goes in order by power. So the squared first, then the cosine, then no cosine. You get what I'm saying? I'm just putting them in order by power on the top. So cosine squared theta minus 2 cosine theta plus 1 I had to think about. What was the sign? Okay. Now I'm not even going to put over sine squared. I'm going to show you something. This is just like having this.
Something like probability or something?
The probability is in geometry, sorry. Probability is geometry topic. Huh? No, trig is in this class. And it's separate between this class and pre-calc. How do you factor this problem? Huh?
That's what I said.
I'm just showing you this. Do you see how that is like that? Do you see how that can be factored? Are you understanding that that can be written in that form? Okay. All right. No, you're gonna get mad at me. I was just trying to show you something. Okay. You have to, when you do this, you have to leave it in the order it's in because it'll get mad at you in the final answer. You get mad. The problem will get mad at you. That's good. You see how the one's in front and we switched it around? It's just something like, so if you say cosine a theta minus 1, or it's negative cosine theta. Yes, it is squared. Well, no, because that's squared, so this is not squared. Yeah, but this is plus 1 here and negative here. Yeah.
It has to be one.
No, they're both negative. Yes, so that means it's the same thing twice in both parentheses. Yes. Yes. You're just both arguing in different ways about the same thing. You're just, you know, your shirt's over the jacket. Okay. The point is, when you write your answer, you have to put it back. You see how this is backwards? You just have to write your answer backwards. I was just trying to show you that this was like this. So you know how normally you do x plus 1 and then x plus 2 or whatever the answer is? You just have to do it backwards. So 1 plus x and then 1 minus x, whatever the answer is. The x just being back because the cosine was in back. I didn't even hear that sneeze. Or I told you, bless you. So the 1 is positive, but the middle's negative. That means you have to have 2 minus signs. It will be the same thing in both of them. So there's a 1 there. I'm just going to write it twice just to show you. You're going to have a minus sign. And what is the thing that's being squared? What's the thing that's being squared? Cosine, so it's just cosine. On a positive, when they do factoring, it's always this easy. It's always 1 and like 1 in sine or 1 in cosine. I meant the type of factoring. What? Just to show you what that was. Like if you couldn't see that it was factoring. It was just a visual. Just a visual. So that's the top. You can write it like this, or you can write it as 1 minus cosine and then put a square on that side. I'm gonna leave it like that. And then the bottom is this. What?
The top is the same thing as 1 minus cosine squared. No, that's not right.
You're close. You're really close. What does sine squared turn into, Isaac? Pyth. What do you know about this guy?
Well, 1 minus cosine theta. If you munch them together, it's squared because they're the same thing.
No, because this one has a square on the top, has a square on the outside. This one has a square on the inside. You're technically 1 step away. You're really close. No, because then you just be undoing what you just did. Leave the top alone. Leave the top alone. The top, we use basic factoring, yes? And to break it down. The bottom, it's all in cosine form, which is what we want. So leave it in cosine form. How can we break down the bottom?
Yeah, it's plus 0. What? That was on. I'm just yelling stuff.
That it'd be 1 plus and then 1 minus. Mr. Roy, why are you sending us off on with something like this?
1 minus
This is
easy.
Yeah, that part's easy, but so you're telling me on your own you could get there.
Easy.
We're not even done with the problem.
We're
There's still
done
another
now.
half. That's what our plan was.
No, you have not. We did a whole problem before this, and you stopped and argued before that. I did tell you this one was going to be bad.
No way.
I was saying, Mr. Raleigh, I can't get mine. I'm just saying.
Isaac, it makes me
Somebody say easy.
even more sad that I forgot your present for you today.
My birthday until Friday.
I know.
Oh, you have another day there? Bring it. What's my present? PS5, new car, bonus point.
Well, that's the 22nd.
Yeah, but you won't see me on Friday.
My present, my post test Thursday.
That'd be funny.
I'm so excited.
Sleeping.
Yeah, Mr. Raleigh, that took 20 minutes.
Okay, let me find. Here, I'll find you an easier one.
It's still so. I'm not gonna lie to you, that's one of the worst things I've ever seen in my whole life. Joe, we'll go with it.
Can I? Let me know when I can move this board.
Well, I mean, you can move forward, but here's what we should.
He said it won't be at my house.
I picked a shorter one for you.
You're so kind.
I like the big fraction ones. These are the ones I hate. They're better than these. I hate these
I
ones.
still look at these and have no clue what I'm doing.
That was a joke.
That's fantastic.
Next to us at the same time while I do it.
I said I was kidding. Jared walked out of class because the temperature was too hot. There's no need to cuss at me, Mr. Big.
All right, let's, we need to know
All right.
this. For the class sake, we do, Jared.
All right.
No.
All right.
Well,
Shut your Trump, Isaac.
everybody, which side do we have to look at?
The way.
Okay. What do you think you're going to mess with first?
That's print. But let me guess.
I mean, it doesn't matter. I would either or. Nope. Cosecant, you have cosecant, cosine, and tangent. We want to simplify all of these to the basic same kind of forms, okay? So that means you have to decide, in your opinion, I'd always go, depending on what's over here, I would always simplify them to sine and cosine form together, right? Because some of them have sine and cosine together, right? So tangent, right? Tangent, how do we rewrite that in sine and cosine form? Okay, that one's the easy one. That's why I asked you that one first. Now, this one, it looks a little scary to think about, but we want to turn it into one fraction. So cosine is already on the bottom. Yes, because it's already a basic trig function. Yes? Okay. What is cosecant? 1 over sine of theta. Yes? So you have a fraction. Hold on, this is about to go to sleep. You're going to have a fraction and a fraction. When you, what's the best word I can say? Like shove that together to make one fraction. Do you know how that's supposed to look? It is not cosine over sine. Because this is in the denominator and this is technically in the numerator. But this is a fraction within a fraction. Yes, that's what it was originally. Yeah, cosecant of. What this does, to get rid of a fraction in a fraction, you multiply the numerator by the inverse of the denominator. Isaac just did it wrong because he forgot about it. This cosine is like a whole number. So what's the opposite of a whole number? An opposite of a whole number, a fraction? A fraction. Which means they both end up in the denominator. Cosine is a whole thing. This is 1 over sine divided by cosine over 1. To get rid of a denominator, you multiply by its inverse. So 1 over cosine. So multiply that by the top and the bottom. So these cancel out. 1's on top. What's on the bottom? Cosine of theta times sine of theta. And then I leave this version alone. Then you ask yourself, can you combine these two things to make one fraction the way it is? No. Why not? How do you make them the same denominator? Because you're going to have to. No. What do they both have? But what does this one not have that this one has? So what do you do to this? No, you just multiply whatever is missing in this fraction, you just multiply it by it. Like if this said 1/3 and this said 1/4, you multiply them by each other's denominators. You're just multiplying by what you're missing. So just multiply the top and the bottom by whatever's missing that you want to make one fraction. Just like you would with numbers. It just has words in it. Yeah, so the denominator that's now the same is cosine of theta times sine of theta. On the left side, we had the number 1, yes. Then we had the minus sign, and then what did the right side turn into? Sine squared. It is neat because we were almost done. This is my equal sign because this guy is over here. 1 minus sine squared of theta. Can that be replaced with something? It is. It's your Pythagorean identity. That can be replaced with this. It's all multiplication. That means you can cancel stuff out if you have the same thing on the top and the bottom. Can it cancel anything out? So I can get rid of the one of this here, and that's canceled out. So you have only one cosine on top. What do you have left on the bottom? I have a silly question for you. What is cosine divided by sine? Cotangent. You do have to write it as cotangent theta equals cotangent. You cannot leave it like that. I only took one board.
For a check mark.
No. Cass, are you done? This one doesn't have any fractions in it. I mean, yes, because you always want to turn it into cosine and sine. This one's like the nicest one I've given you. Oh no. Calculus is so much harder than this.
We've already got 4 math periods,
Oh, I love pre-calc.
right?
It was my favorite class.
We already got 4 math periods.
You do know you can't play sports next year if you don't take math. You don't have credits. You do know that, right? You already have to take extra classes. Yeah, but 5. Yes, you did. Every year they check and see if you're taking enough classes. Yeah, but your electives don't count up, especially if we're doing the same thing we're doing now.
Yeah, Tigers have one class too.
Yeah, it's because they made this mistake this year. They're not going to do that next year. They're going to kick you out next year. Well, no, this year it's 2.5 per semester because it's semesters. Or 3, technically. Okay, you should be able to do this. Left side, turn it into sine and cosine only. I don't pick them in the quiz. I just give you the quiz. PE is only half a credit. Math. That's 2 credits. What class are you going to take? Your electives aren't enough. You have to take a core class. That's only 1. You're going to have to. Yes. That's still not enough. You need 5 credits all year. That's 2. Half. Yeah, PE is only half credit. No, that doesn't count for your credits to play sports. It helps you graduate. It does not help you play sports. Oh my goodness. Just take consumer math. It's not hard. Okay, what do you do? Do I do anything to cosine squared? Okay, I'm just going to write it as cosine squared over 1. How can I rewrite secant? Okay, cosecant. What am I going to write? Okay, if this, technically these are all multiplied, yes? So they're really one big fraction. What do you notice? I can take this whole cosine out and that. So what's on top? What, you have cosine of theta on top with a bunch of ones. Oh my.
See, we come up with those, Mr. Ronnie. We put those fat fractions in there, and it's just no good.
Nope.
This has been the greatest start to a day, I think.
You had 3 days off.
We got like 4 days off.
Can you count?
You take the end of Friday night and Tuesday morning.
Tuesday morning.
Yeah, Luke, you were up
You.
at 2 o'clock this morning.
I could have done too until they No, we got out of school.
Oh, okay. That makes like a few days.
It doesn't, but you didn't have a half a day this morning. Except for you didn't have a half a day this morning. My third period? Oh boy, no. I'll miss Kayla. No, because I get to have them again. They're only freshmen. They're only freshmen. This one, you actually have to simplify both sides. Yeah. Do the right side first. It's easier. I mean, they're both pretty easy. It's a very short problem, both sides. I would do the right side first. What do you know about cotangent and tangent? So this is cosine of theta over sine of theta. Too bad you still have to show your work, huh, Lincoln? You just have to show this. And then you know that that turns into. Okay. Then deal with the left side. You could also do 1 over tangent and tangent over 1. You could also do that. Now let's rewrite the left side. What form do you want to put cosecant and cotangent in? 1 over sine squared of theta minus. Oh, hold on. He knows the answer. What? Yes. There are 2 ways to do this problem. He just answered it in 1 second. If you can't see this, this is the other way to do it. Cotangent is cosine squared of theta over sine squared of theta, yes? What do you notice about the denominator? No, they're the same. Then, what do you know about 1 minus cosine squared? What can it be replaced with? You can replace it with sine squared of theta. What do you know about that? If you have the ability, like Isaac did, there is this trig function. I was proud of you. I'm giving you a sticker for it. This is a Pythagorean identity. This guy right here. If you move cotangent to the other side, it equals that. Look, here to here. So that's a Pythagorean identity. So he could have right away replaced this with 1 and been done. Because that's what Isaac realized. That was the last one.